Assalamualaikum warahmatullahi wabarakatuh. My name is Ifa Fikri bin Iza, and today I will present to you on two questions about digital system. Okay, here is the first question, and the question said that design the logic circuit for an alarm circuit used in vehicles to detect certain undesirable conditions. The circuit has three inputs, which indicates the status of the door by the driver's seat, the ignition and headlights respectively. Designed so that the alarm will be activated whenever either of the following conditions exist. And the first condition is the headlights are on while the ignition is off. And the second condition is the door is open while the ignition is on. So basically this question asks us to design a logic circuit with three inputs, which is the headlights, the ignition and the door. Okay, here is how to answer this type of question. First, as I said earlier, there is three inputs, which is the headlights, the ignition and the door. So we just label it as A, B and C, which is for headlights, ignition and the door. So to solve this type of questions, we need to draw a table, and to find out how many outcomes for the input, we will just use 2 to the power of the. So here is how to solve this type of question. We have, as I said earlier, we have three inputs, which is the headlights, the door and the ignition, and we need to draw the table to make a logic circuit. So to draw the table, we need to identify how many input outcome. To identify how many input outcome, first we have to make 2 to the power of the number of input, which we will get 8. So there will be 8 input outcome. First, we just need to put in 0, 0, 1, 1, 0, 0, 1, 1, the same sequence for the first part and the second part. And for B, we just put in the same as A for the first part and the inverted of A for the second part. And for C, you just put in 0, 1, 0, 1, 0, 1 and 0, 1. So let's take a look back at the state which the condition will be on. First, it states that the headlights are on while the ignition is off. This means that A will be 1 while C will be 0. And first we find it on the table where A is 1 and C is 0, which means it's here for example, and we put it 1 for the result. And let's find another one, which is also this, and we put it also 1 at the Z. And let's take a look at the second stage, which says that the door is open while the ignition is on, which means that while B is 1, C will also be 1. And from the table we will see here Z, B and C is 1, so Z will be 1, and here is also B and C is 1, so Z will also be 1, and the rest we just put in 0, 0, 0, 0. So we have sketched the table, and next we just need to make the equation by using SOP, which is Z equals to the result of Z is 1, and we just put in the product of A, B and inverted of C, which is states here A, B and inverted of C, and here also Z is 1, which means it's A, B and C plus A, B and C, and here we have inverted of A, B and C, and also here we have A, inverted of B and inverted of C. From this equation we need to simplify it by first we identify C, we make a group C AB plus AB inverted of B, and next we have this C A B plus AB. So as you can see here, we can further simplify this by making it C A and plus C B. and here we have the simplified equation, and then we can design the logic circuit. We have the product of C and A and the product of C and B, which is the AND gate. So first I need to use another. So as you can see from this equation, the product of inverted of C and A and the product plus the product of C and B, which is this, is from an AND gate, both of this, and after that it will go to an OR gate, which is the plus sign. So just first we have three input A, C. I put it C at the middle because we have to connect C to A and B both, and B. You put it to AND gate as I said earlier, and A will go to the first AND gate, and as you can see the inverted of C, which will have this, which from C, and both C, the product of C and B. And here is the first part. Here we'll produce the result of the product of A and inverted of C, and here it will produce the product of C and B. So we have the product of inverted of C and A and C and B. So we just have to add the plus sign, which is the OR gate. Connect them both to an OR gate, and we have the logic circuit which leads to Z. And here we will see that the product of A and inverted of C will the sum of product of A and inverted of C, and C, the product of C and B. That's it. Okay, this is the second question. The addition and subtraction operations can be combined into one circuit with one common binary adder by including an exclusive OR gate with each full adder. A 4-bit adder subtracted circuit is shown in figure 1 below. The mode input M controls the operation. When M equals to 0, the circuit is an adder, and when M equals to 1, the circuit becomes a subtractor. In each case, determine the values of the four sum outputs and overflow V. Okay, as the question said earlier, if M, the input of M is 0, this circuit, the circuit from figure 1, which is this, will be an adder. And if the M is equal to 1, this circuit will be a subtractor. So first we settle for the case A, which is say that if M equal to 0, this circuit will be an adder. So just simply add all of this full adder. Okay, one step by step. Okay, first M is equal to 0 and A node equals to 1. Oh, sorry. First, we just assign 0, 1, 1, 1 to all A3, A2, A1 and A node respectively. 0, 1, 1, 1, and for B 0, 1, 1, 0, 0, 1, 1, 0, and M will assign as 0 as said in the question. So after that, we just need to identify after the XOR what will be the output. So when B naught is equal to 0 and M equal to 0, the output will be 0 because this is an XOR. When both of the input are the same, the output will be 0. So we take a look after that. B1 is equal to 1 and M equal to 0, different input, so it will be 1. B2 equals to 1, M equals to 0, and the output will also be 1. And B3 is equal to 0 and M equal to 0, the output will also equals to 0. So after that, just simply sum all of this at full adder. So 0 plus 1 plus 0, we will get 1 with the carry of 0. And after that, 0 plus 1 plus 1, we will get the sum of it is 0 with the carry of 1. 1 plus 1 plus 1 will get the sum of it is 1 with the carry of 1. 1 plus 0 will get the sum of it as 1 and the carry of 0. So let's take a look at the final carry. The first input is 0 and the second input is 1, so we will get the output as 1, as this is an XOR gate. So we get the answer just simply write back from S3 to S0, which is 1 1 0 1. So this is the sum of A and B. Let's check it. So the input of A is 0 1 1 1 and input of B 0 1 1 0 plus, so add them. 1 plus 0 is 1, 1 plus 1 is 0 with the carry of 1, 1 plus 1 plus 1 is sum of it is 1 with the carry of 1, 1 plus 0 is 1. So is it the same? Yes, so the answer is correct. So this circuit is really an adder circuit. Okay, let's move on to the second state, which the second state, the question said that if m equals to 1, the second state will be a subtractor. This circuit from this figure 1 will be a subtractor. So we just, as the first state, we just put in the value for A 0 1 0 1 0 1 0 1 and for B 1 0 1 0 1 0 1 0. And first part is, for the first part is just identify what is the output at each of the XOR gate. So for B naught is 0 and M equals to 1, different input, so it will become 1. And here same input 1 and 1, it will become 0, and at here B2 is equal to 0 and M equals to 1, the output will be 1 as it is the different output, and here 1 the same input as the 1 and the output will be 0. So after that we have list down all the output for the XOR, just add all at the full adder. 1 plus 1 plus 1, we will get the sum of it is 1 with the carry of 1. 1 plus 0 plus 0, the output will be 1 and the carry will be 0. 0 plus 1 plus 1, the sum of it will be 0 and the carry of 1. 1 plus 0 plus 1, the sum of it will be 1 and the carry of 0. So at the final carry we will get different input, so it will become 0. With different input we will get 1. So we will get the final answer as 1 0 1 1. So let's check if it is true or not. So basically, to check it, we have to use A plus negative B, which means also that means that A minus B. So to get minus B, we just use 2's complement for B, which is first, in my way, we just copy the number until it reached the first one, 0 1, and after that we just inverted the rest of the number. 0 will be 1 and 1 will be 0. So here is the 2's complement for B, and just add A plus the 2's complement of B, we will get 0 1 0 1 and the complement and plus 0 1 1 0, and we get 1 0 1 1 with the carry of 0. So this is the final answer. The final answer is the same as the one in the circuit. So yes, it acts as the subtractor, and the answer is 1011. That's all from me. Thank you.